All right. Okay, well, happy Friday. Hope you guys are doing well. Let's go ahead and take a look at today's lecture. I'm going to just clear all of my outputs so we can kind of produce them as we go through. We've talked about lists, we've talked about strings, we talked about dictionaries. And today I want to talk about tuples, okay? And tuples are a lot like lists in that you can put a whole bunch of stuff in tuples. They can contain different types. Tuples are ordered and they preserve their order. So you can think of it kind of like a stack, and you can say, like, give me the third item, give me the fourth item. Contrast that to a dictionary. Dictionaries, you can't refer to items in the dictionary by their position. You can't say, hey, what's the fourth word in the dictionary? You have to always give it a key. You always have to give it a key. Tuples, you ask, hey, what's the fourth item? What's the index 3 position, or something like that, okay? They are different from lists in that they are immutable, okay? So you cannot append to a tuple. You can't modify or reassign values in a tuple like you can a list. And tuples are created by using curved brackets, or we might call these things parentheses. And they're also, if you just kind of give it a sequence of things separated with commas, Python will create a tuple as well, okay? Now, you might think, well, if tuples are just lists that can do less, right? Like lists feel like they're more versatile. You can modify them, you can do append, you have these different methods that work for a list, right? You can call, list name dot append, list name dot insert, list name, there's a whole bunch of stuff that you can do with a list. And it feels like, oh, well, tuples, you can't do as much. Like, why would I ever want to use a tuple? Shouldn't I just use a list for everything? And I would say a lot of times, in a lot of cases, yeah, you can use the tuple and the list like interchangeably and not feel any kind of dramatic difference between the two, okay? However, there will be specific times where you want your thing to be immutable, where you don't want, you want to make sure that it can't be changed. And so anyway, let's do that. Okay, you can also create a tuple by putting a trailing comma. So if I say T1 is quote A, the string A with a comma after this will produce a tuple of length 1. Okay, length 1. So these lines up here are equivalent. They both produce equivalent tuples. This creates an entirely new tuple here, and you can ask, hey, what is the type of this? And it will say it is a tuple. Okay, a tuple. And it is length 1 tuple. Okay, so tuples just have a length. If you do this and you don't put in the trailing comma, then it's just going to be the string. Okay. So if you want a length 1 tuple, you do have to put in a trailing comma in order for it to be a tuple. Okay, otherwise it'll just be this thing, if you just want something length 1. Okay, just like anything else, you can also create an empty tuple with using kind of the creator function. And you can call tuple here, and you get an empty tuple. There you go. But unlike a list, with a list, it's sometimes helpful to create an empty list, because then you can just append things to an empty list. If you create an empty tuple, there's not a ton you can do with it, because you can't append it, you can't modify it. It's that empty tuple is forever going to remain an empty tuple. Okay? I mean, sometimes you might want that, but there's not a whole lot you can actually do with it. Okay, so here you can just put insert anything, any kind of iterable into a tuple, and it will make a tuple out of it. So here I'm going to put the string hello into tuple. All right, now this is very different from doing parentheses with the string hello, comma. Okay, so So if I did this, okay, then we get that, right? But if you call tuple on this, so using parentheses like this and using tuple on this, very different kind of results here. So when you call tuple on something like hello, it turns it into it separates out the elements into a list here. Same thing happens when you do when you call list on a string as well. So I don't know if students or people are aware of this, right? So this is just a side. I guess I'm getting sidetracked here, but that's very different from creating a list containing the word hello, right? So using square brackets to create a list with the string hello is very different from calling list on an iterable, which is a string containing the letters HELLO. Okay, so tuple on this will separate out the elements of the string into its characters, and so on and so forth. Okay, you can call tuple on a range object, and it will force Python to evaluate the range object and make a tuple out of it. Okay, so again, if you don't call tuple, if you just ask Python to create a range object, you get a range object. Python is lazy. It's not going to evaluate that range object until it's forced to do so. Calling tuple on range or calling list on range or something like that will force Python to evaluate everything in that range thing. Okay, similar to any other kind of objects like zip objects and stuff. Okay, here I give it a list, put list inside a tuple, and that will basically convert the elements of the list, or convert the list into a tuple there. All right, you index elements in a tuple just like you would index or slice elements in a list. So here, if this is my tuple, the index 1 position is going to be apple, and you can call index 2 through 5. Okay, 2, 3, 4, 5, and this will give you a tuple subset going from 2, cat, and dog. Okay, so you have this. All right, lists are mutable, tuples are immutable. So here I'm going to create basically equivalent tuples and lists. So here I'm just redefining, so all of these things I've been doing bad practice of just having the terrible name of T and L and stuff, which again, when you name your objects, use better names than just a single letter, because you'll have no idea what these things are. But anyway, here I'm going to create a tuple called T and a list called L. And here, every single time I've been doing this, I've just been defining entirely new tuples. Okay, every time we do this, we're not modifying any existing tuple. I'm just creating an entirely new tuple each time. And so here I've got this tuple, and here I've got the list, and they're basically the same thing, except this one's a tuple and this one's a list. Oh, and by the way, I had integer 0, and then kind of apple, 2, cat, dog, 5, 6, kind of like index 1 is A, and index 3, third letter is C, and index 4 is D, and then these are all. So it's just kind of like when you see these things, oh, okay, that was the index 3 third position, or this was 5 is at the index 5 position. Okay, so anyway, we have that. So with a list, you can say, hey, I want to change the value that's at index 0, okay, and I want to change that to 100. We can use assignment in conjunction with list subsetting or slicing. And so here, if I do that, this object, which is this list, that first value changes to 100. Okay, you try to do that with a tuple, and it says, nope, you cannot do that, right? This T points to a tuple that exists in memory, and you cannot, once that thing is defined in memory, it is forever stuck that way, okay? Once you have a tuple defined. If you want to, quote, change a tuple, you can't do it. You cannot change a tuple. The closest thing you can do is create a copy of the tuple that's different. Okay, that's the closest thing. Kind of like a string. Once you create a string, you can't modify the string. You can give me a capitalized version of the string, but that doesn't modify the original string. You can give me a lowercase version of the string. You can create an entirely new string that's maybe a subset of the original string. And tuples are similar. You can't modify that tuple that you created. You can create like a new kind of version, a copy of it that's a little bit different or something. But you have that. Okay. So again, lists you can modify. You can do things like append the letter X to the list, and it appends the letter X to the list. And if you try to do something like tuple.append, whatever your tuple name is called, it's going to say, nope, there's no attribute append. You're not allowed to do that. Okay? Again, you can just replace one tuple with another. So here I have this tuple T, and I can say, hey, slice it from index 1 through the end, and then add a tuple. So here's a tuple of length 1, and we're going to do this. And so this will create an entirely new tuple, and we are going to take this entirely new tuple and give it the old name T. And so T is now a new tuple that has A, and then apple 2 cat dog 5 6. Okay, so that's an entirely new tuple, unrelated to the other tuple. Okay, with tuples, you can also do relational operators. Is one thing greater than or less than another? And it kind of works like how does like alphabetizing something, right? So here I've got 0, 1, 2. Is that less than 0, 3, 4? It compares the first element and the first element. Then it goes to the second element and the second element. And because the second element, 1, is less than the second element here, 3, this is going to come back true. Okay? So this would be the first one. You can think of like A, B, C. Does that come before, if you alphabetized it versus A, what I'm trying to do, A, D, E, okay? So yes, you would alphabetize this before the other one, okay? And then here I've got, it's like A, B, Z, and over here I have A, D, E, okay? Well, it doesn't matter that this is Z. You just go A to A, and then B comes before D. So the letter after B doesn't really matter. So this next one, even though I got like 2 billion here, or 2, what is that? 2 million, doesn't matter, okay? Here, if I go, now I have 0, 500 this, okay? That's going to be false. And similarly, how does this work? I've got, if I take tuple of ABC and tuple ABCD, then ABC comes before ABCD. All right, let me give you, actually I need to pull this up. All right, I'm like choking here. All right, this is a really, really, really common problem, and this is tuples make this nice and easy for us, okay? So sometimes you need to like swap the values, like A and B. So without tuples, if you naively did something like A is 5 and B is 1, and then you wanted to just swap these things, so you're going to do something like, and I think we've done silly things like this, right? You say, okay, well, B is going to take on the value A, and then A is going to take on the value B, and then what is A, and what is B? we didn't successfully swap, because once I assign B to A, or A to B, this value 1 just gets lost, the value that was at B. So if you wanted to like swap the values, you'd have to do something like A is 5, B is 1. You would temporarily assign, say, A to a temporary value. Then you'd assign B to A, and then you'd take that temporary value and assign it to B. And then you would have swapped the values. A now has the value 1, and B has the value 5. Okay? But with tuples, you can just say, hey, A is 5, B is 1, and then this operation, you say B comma A takes on the values A comma B. This gets evaluated simultaneously. It's not A gets assigned to B first and then B gets assigned to A next. This thing, I don't know how Python does it, but this gets operated simultaneously, everything in this line. So then when you do that, the values between A and B just get swapped. And there's no kind of need to kind of create a temporary holding cell in order to kind of reuse that value later, right? And so, so that's really nice. And you will commonly see this, I guess, tuple unpacking and assignment. That's a common thing that happens in Python. Okay, all right. Now let me give you your first view quiz answer, which is the letter E. E as in elephant. E is your first view quiz answer. E. Okay, so you can take something like this. This is an email address, and you can call, say, string split. Okay, and when you call string split, it creates a list. It's going to put kind of I don't know what you call this part, the username, and this is the domain or whatever. So it split it at the @ sign, and so it split the email address into these two components. Okay. What you can do is you can unpack what this thing returns. So address.split is going to return this list, but you can just kind of catch them into a tuple. And so this is going to just assign the first element to uname and the second element to domain. And again, this is a simultaneous operation, but now I have kind of these two names that refer to objects. I got uname Miles Chen, domain stat.ucla.edu. Okay. We already have a divide function, but here I get to kind of make up my own thing here. And so this will just do like division with, I guess, integer, division with remainders and stuff like that. So we're going to say x divided by y. And so here I get the integer floor division. This will give it, you know, when you do like, say, 80 divided by 9, all right, you're going to get 8 remainder 8, okay? And so the integer part will be, I guess that first part, 8, and then the remainder will also be 8. 80 was a bad example. Okay, 77 divided by 9. 77 will give you 8 remainder 5. Okay, I'm doing my math correctly. Okay, so the integer part will be 8, and then the remainder will be 5. Okay, okay, 23, 5 will give us what? 4 remainder 3. So A is 4 and B is 3. Okay, and so you have that there. There's already a built-in function that does exactly this, so there's no need for me to code this, but you can see that when you write a function, you can return multiple values. They get gathered together into a tuple. Okay, so you know, in R, when you had a function, it was only allowed to return one value. In Python, you can have just one return line. You can put multiple values in that return line, and that gets packaged up into a tuple. But again, you can kind of take that tuple and unpack it as soon as it runs. So I could have also done like j is equal to my divide 23 comma 5. Okay, and j here would be this tuple. I could call it this way. And then I can just get A separate from B as well, okay? So we'll have that. Okay, so there's really only two methods that tuples support. One is index, that will tell you what is the index position of the first time it encounters some element. And then count is how many times did that element appear. So here, I'll just do dog again, and 5, and 5. Okay. So t.index, it's just going to give us the first time it encounters dog. Okay, and that's at index position 4. Okay, t.count 5 is going to see how many times does it encounter the integer 5. So we have the integer 5 here, and I have the integer 5 here. So it's just going to give me a count of 2. This string 5 doesn't count, right? So t.count 5 gives me 2. I can say t.count quote 5, that occurs once. T.count quote 9, that occurs 0 times. Let me see. T.index, if you give it something that doesn't exist, so we've seen this with lists, you'll get value errors with t.index. Let me see. Is there a get? No. Yeah, there's no attribute get. Okay. Okay, these are functions that support tuples and other iterables. They don't modify the tuples, okay, but they give you information back about the tuples. Okay, so here I've got a tuple of some digits. I've got a list of words, and you can do stuff like, hey, what is the length of my tuple? And I'll say, oh yeah, there's 7 digits in there. If they're all numeric, you can sum them up. Obviously, you can't call sum when you have a bunch of strings. Okay, it says, yeah, that's not allowed. At trying to add those up. You can take some digits, this tuple, and you can call sorted on it. Okay, sorted on the tuple will give you back kind of a sorted version of the tuple, and so in order from least to greatest, the values in the tuple are 2, 2, 3, 4, 5, 7, 9. Notice that it returns a list, okay? So even though the original thing was a tuple, when you call sorted on the thing, it gives us back a list. And that's very different from list.sort. I think I've emphasized that list.sort takes a list and sorts it in place. Tuples obviously will not have a .sort method because you can't modify tuples. Okay, just to show you that the original tuple is unchanged, I can print out the original tuple and it still remains as a tuple. Okay, if you take a list of words or a tuple of strings or something like that, you call sorted, it will put them in alphabetical order. You can call the minimum, and that will give you the smallest value, or max, and it will give you the largest value in the tuple. If you call it on strings, then min or max will give you something like the thing that comes last in an alphabetical list. Okay, if I just create another tuple, all right, and if you give it a mix of tuples and strings, or I mean numbers and strings, then you can't do stuff like sorted. Okay, it's going to say I can't sort between strings and numbers. All right, here is I'm going to create 2 dictionaries. One dictionary has numbers as the keys. The other dictionary has letters as keys. We're going to say what's the length of the dictionary, and this will give us the number of items. Each of these dictionaries have 3 things. We're going to say, hey, what is it sorted? Okay, and it's going to give us the list of keys in sorted order. I guess I could just change this to 5 here. Okay, and it will give you the list of keys in sorted order. Same thing with when you call dictionary, it'll give you the list of keys in sorted order. And then the maximum number is going to be kind of the largest key value, okay, the maximum key, whatever that is. And again, if I have a mix, Now if you call sorted and you try to sort the key sorted, then it says that, I can't do that. Okay. All right. We've seen some of these things before. If you take a list and you use some of these math operators like plus or star, it kind of it will duplicate or it will append. So if I have L1 is a list ABC and L2 is a list DEF, I can call L1 times 2, and it's going to just take ABC and kind of extend it with ABC. Okay. If I do L1 plus L2, it's going to append these two together, stick them together, and we'll get ABCDEF. Okay, same kind of thing happens with tuples. I can take a tuple ABC and a tuple DEF. T1 times this. T1 plus T2 takes those things and does that as well. Okay. Now, if you try to take a list and add a tuple to it, so if I take L1, which is list ABC, and T2, which is tuple DEF, doesn't like that. Okay, it doesn't. You can't concatenate lists. It says you can only concatenate a list to a list. Okay, so what you have to do is you just have to convert the tuple into a list, or vice versa. Okay. Tuples allow us to provide variable length arguments into a function. Okay. And so this is where, like, the immutable nature of tuples are an asset, because you don't want to have the arguments, I guess, changing in the middle of stuff here. Okay, so this is kind of this is silly here. Here I'm going to create a function called print all. Okay, and it's going to just take in this thing called args here. And if I try to run print all, it's just going to take the args and just print them. It's going to say, hey, what are you doing? Okay, you're giving me 4 arguments here. Okay, but I can only do args. Okay, so what you can do here is you can call star args, and if you put a star in front of an argument in the function, okay, it's going to allow you to put in multiple values here, and it's going to gather them together into a tuple. Okay, now when you do something like this, the convention is you call this thing star args, but there's nothing magical about ARGS as the name that we use. Okay, so that's just a conventional thing. It helps other people understand. When they see args, a lot of times they'll think this is going to be a multiple length thing, but so that's why we like to stick with convention. But again, there's nothing inherently wrong about it. Okay, so here I'm redefining this print all function. Print all as its input argument will be, it's going to take in, if it sees multiple things, it's going to gather them together into a tuple. And so when you do this, it gathers these 4 elements into a single tuple, and it prints that out. Okay. If I did print all just 3 here, okay, you can see it gathered, even though there's only 1 element, it gathered it into a tuple, and it prints that out. Okay, and so this is kind of dumb here, but probably what you would do is you would then, within your function that takes in a variable length argument, you will probably put in some kind of loop apparatus to iterate over all of the elements in this variable length input. Okay, so here I'll just create a slightly more complicated function called print lines. And what this says is we're going to take in some arguments. I don't know if it's going to be 1 thing or 50 things. It doesn't matter. But whatever it is, it's going to gather it together into a tuple. And then we can iterate over that tuple of variable length. And then so for each element in that tuple, we'll just print it out. Okay, so again, very, very simple thing. But I mean, here, I mean, we can just do, I can just make it a string, and then we can just make it capitalize. Okay. And so here, I can give it to the arguments hi and goodbye, hi, I love you, goodbye, right? And so now it works like that. Okay. Here we can just give it a whole bunch of these numbers here, and because I convert these into strings, this is fine. Okay. So yeah, however you want to do it. If you want to just provide one, it's still whoops. That doesn't work. Okay. The you have the opposite. Okay. I guess the complementary feature or functionality of gather is to scatter, and that's also happens with the star operator. Okay, so remember we have this silly little function, my divide, and just you do like 23, 5, and if we wanted to do something like this, we could do my divide, and I would do 23 and 5. Okay. So here, this function is expecting 2 arguments coming in. Okay. Here I'm going to create a tuple, t, and t has the values 23 and 5. Okay. If I try to call my divide on this tuple t, it's going to get angry with me. Okay. It says my divide is expecting 2 arguments, and you gave me one argument. It was a tuple, but it was just one argument. And so, when you call a function, you can call into a function. You can take the tuple that has both of your values in it, and then you can scatter that across the arguments x and y. And so I can call my divide star t, and then this will work. Okay. So these are. It's a tiny bit confusing because over here they're opposite things, but they and their use cases are similar functions, but they do the opposite thing. So here you use star when you define your function so that multiple values get gathered into a single tuple, and then over here, if you have a function that accepts multiple arguments, but they're currently gathered together into a single tuple, you use star to scatter them across those multiple things. Okay, so obviously this is expecting when you scatter them, it's going to do it positionally. Okay, so if you did like 5, 23, it's not going to work, right? You can't. That's not going to work well. Okay. I've given you just one view quiz answer so far. Okay, second view quiz answer is the letter B. B as in bear. B is our second view quiz answer. Okay, we've talked about zip functions. Okay, so zip is this kind of function. You take 2 or more sequences and it interleaves them. Okay, so kind of like, again, just like a zipper, or it's like when you're trying to merge into traffic, and we're like polite, right? Like when you're merging onto a freeway and there's huge, super slow traffic, it's supposed to, the way it's supposed to work is you let one car on this side go in and one car going in this side and one car going in this side, one car going in. And then if you are not a nice person, you might like try to squeeze in 2 at a time or something, and I will judge you in my brain. But I also don't, I'm not a road rage person, so like people do just, I mean, in LA, right? Like if you're affected by road rage, your life is just sad for anytime you're on the road, because there's so many, aggressive drivers, we'll say that. Okay. All right, so anyway, but when zips are lazy. zips are lazy, so or Python is lazy, and so it doesn't evaluate zip functions until you tell it to. So here I got ABC, I've got a tuple 0, 1, 2, and so and when you do this, and you say, hey, for each element in here, I want you to print this out. It prints them out as tuples, right? It creates a tuple with A and 0, a tuple with B and 1, a tuple with C and 2. STQRSTU. Okay. All right. So I can also create apple, banana. What comes with C? Corn? I don't know. Is there a fruit? C? What? Cantaloupe. There we go. Oh, now I have to spell that out. Is that at Canta? I don't know, whatever. Okay. For pair and zip ST and U, print out the pair, and it interleaves. You can you can zip together not just 2, but like 3 things together, and it's like collating multiple stacks of paper and stuff. Okay, so yeah, if you take the zip and you throw it into a list, it will do the same thing. Here you got a list of the tuples. It does not like it, okay? Or I mean, it won't give you an error, but if you have so here I've got this string with 4 letters, string with 3 letters, and then I say zip this, okay? It's gonna go letter by letter, but it stops at the shorter one, okay? So it goes capital A with capital E, N with L, N with K, and then it goes that, right? Here I have a list of tuples, A0, B1, C2, and then you can iterate through that and unpack it as well, okay? And it would have also worked with, so any of these things for, I guess, letter, number, fruit in zip, ST, and U. I don't know, print the letter is letter and number is number and fruit is fruit. Oh wait, what happened here? Oh, I used this as T. I need to do this. Okay. Okay. Automatically put spaces in between these things. Okay. So that does that. Oh, okay. I already did this. Okay. So iterable 1, 2, 3, and 4, and you get this thing. Okay. Oh, coconut. That was the answer. All right. Okay, a handy little thing is sometimes you want to see is the second element of this thing the same as the second element of this thing, or is the third element of this thing? So, we can call this has match, and we'll just kind of zip together T1 and T2, whatever our iterables are. We'll unpack them as X and Y, and then we will just go through each kind of pair. Is X equal to Y? And if so, if you encounter that, just say true, exit out. And if you get through the entire for loop and you don't encounter a match, then return false. So I've got A, B, C, and D, E, F. Is there a match positionally? Nope, there's not. What about A, B, C, and D, E, C? Yep, when we get to C, there's a match. What about A, B, C, D, D, C, B, A? Well, we got common elements, but the first element doesn't match the first, or the second doesn't match the second, or things like that. So we don't get a match there, okay? There is another function, enumerate. And enumerate is like using zip with a range object, okay? And so it's just kind of like a shortcut for what if you wanted to take morning and then you wanted to list off every single kind of thing. Okay, again, like all of these other things like zip and whatever, it's lazy, it doesn't evaluate it, but you can kind of iterate through it. And so it's just kind of, again, you're taking an iterable and you're zipping it with a range object of the same length. So you start off with 0. It's going to say, okay, what is the length of morning? Morning is 7 long, so it's going to create a range 7 object. So that goes from 0 to 6, and it's going to go M goes with 0, O goes with 1, R goes with 2, so on and so forth. All right, so you have that. Here I'm going to take enumerate ABCD, and forcing Python to print it all out, we're going to call list on it, and so you'll get 0A, 1B, 2C, 3D, so on and so forth. This is, again, enumerate is basically calling range on a range object of the same length and then zipping it together. Okay, but enumerate's just, there's a lot of times where you want to do something like this, where you want to create a range object of the same length and then zip it, and enumerate just does that for you. So that's really really nice. Okay, dictionaries. You can use tuples as the keys here. All right, so here's my dictionary. Dictionary.items is basically a sequence of tuples, and so you can kind of iterate through dictionary.items, and you do that. You can use enumerate, throw that into a dictionary, all right, and so now you have all of your keys will be basically 0 through whatever, and then the values will be what was inside whatever your iterable was that you enumerated. Okay. So here we talked about, can you build a dictionary that swaps all of the things here? So here I'm going to take right. So right now D is 0E, 1F, and 2G, and I can kind of unpack all of these things into the key and the value, and then here I want to create a swapped dictionary where I take each of these things and I reverse them. Okay, and so now I have E goes with 0, F goes with 1, and G goes with 2. Okay, and I could have also just done this by zipping them in the reverse order. Now, what would happen if I had this? EFG, EFG. So now my dictionary is 0 is E, 1 is F, 2 is G, 3 is E, 4 is F, 5 is G, and then I call this this thing here. What is the resulting dictionary going to look like? Yeah.
Is it going to be shorter? It's only going to have the letters.
Yeah, because it's iterative, and remember, dictionaries aren't allowed to have duplicate keys. We're not going to have an E0 and an E4. It's just going to have, as it reads through it, element by element. Okay. Basically, first it creates E and 0, but then as it goes through and encounters E again, it's going to replace that. And so at the end, you're going to just have E3, F4, and G5. Okay. So yes, you're only going to have 3 things there. So I guess one thing to just kind of watch out for or something like that. Okay, you can create dictionaries out of sequences of tuples. You can create dictionaries out of zip objects, and we showed you that in Wednesday's lecture as well. Okay, all right. So this is where having a tuple that's immutable can be beneficial, because so here's an example. All right. You might have some kind of function. This function is stupid and it's easy to evaluate. But there could be some kind of mathematical function or something where every time you call it, it takes a while to calculate, right? So you might have like this Taylor series infinite expansion, and you might say, I want to get really accurate and I want to go out to like 500 places or something. And it takes a while to compute that. And so what you might want to do is you might want to be like, okay, these are the known values. Like we computed it for this thing, and we spent the time, so I know the answer. When you ask me what is it for, 0, 0, I know the answer, and that way I don't have to actually recompute it at that time. I can just retrieve it. And so this is how we can do something like this. We can create a dictionary of like known values, known solutions, and we will create a function that takes in whatever we're doing, x and y. We'll create a tuple out of those arguments, out of x and y. And if that tuple is one of the known keys, okay, so we're going to say if that tuple is in known, okay, is one of the keys in the known dictionary, then I will print out value already exists in the dictionary, and we will use that and retrieve the value associated with that key. So then I'm going to just say key known, which is my dictionary, pull out the value associated with key. If it's not, and then we'll print the value must be calculated, and the results here, we'll do the computation x squared plus 2y. Then we will add that into our known dictionary and return that result there. Okay, so if I call f on 0, 0, we'll say value already exists in the dictionary. Let me just, so right now our dictionary is this. If I call f on 1, 2, it'll say value must be calculated. And I can say, hey, what does my dictionary look like now? Now I've got 0, 0, and 1, 2 evaluates to 5. I can evaluate f on 1, 2 here, and now it says, well, this thing already exists in the dictionary, so it just retrieves it, okay? And again, there's our dictionary there. So this is an example where using tuples provides an advantage over lists because they are immutable. And again, as far as dictionary keys go, dictionary keys have to be immutable. You don't want to have a situation where the thing that you're going to look up, changes values. Okay. Okay, that is it for today. So we will go ahead and wrap things up here. Have a great weekend, and we'll see you on Monday.